Hello, I'm Dr. Kristen Lee Raug. I teach human evolutionary biology at the University of California, Davis. This video is a basic introduction to the primate taxonomy, and it's intended for beginning students. But the system of primate classification can get a lot more detailed than what's presented here, so if you're interested, I highly encourage you to pursue more advanced study. I hope you enjoy this guided tour of our fascinating order, the primates. So the first thing we're going to look at here is to compare a monkey, which is of course a primate, to a dog, which is a mammal, but obviously not a primate. So what sort of differences can we see between their skeletons? So the first important thing that you'll notice is that primates have prehensile hands, which means they can grasp and hold on to things just like this spider monkey is. The dog does not have prehensile hands, right? Dogs can't actually grasp things with their hands. Primates also have something called pentadactyly, which means you have 5 digits on your hands and feet. All primates have that characteristic. They also have nails on their digits instead of claws. Like the dog has claws, right? Primates have nails, which are flattened out and serve to protect the tip of the finger. Some other things you might notice that distinguish primates is sort of the flatness of the face, right? As opposed to the dog, the snout is elongated out of the front. And the elongating in the front of the face is called prognathism, right? And so the dog is more prognathic and the monkey is less prognathic. You can also see that the brain case, the area in which the brain is actually contained within the skull, is quite a bit larger in relation to the overall skull than it is in the dog. The brain case relative to the size of the skull overall is diminished in size relative to the primate. Other important characteristics of primates are the forward-facing eyes. Rather than on the dog, they're a little bit more to the side, and you can imagine other types of mammals like deer or oxen, something like that. Their eyes are actually on the sides of their head, and that gives them vision around towards the back of themselves, which could be important for them to avoid predators. Primates, on the other hand, the eyes are rotated towards the front of the skull, and this gives them overlapping fields of vision, which is good for depth perception and improves depth perception. So that's related to a whole cluster of traits that go along with a lifestyle of living in the trees, which is called an arboreal lifestyle, right? You live in the trees. So depth perception becomes very important when you're jumping from branch to branch, right? You wouldn't want to, if your depth perception is bad, you might miss the branch and fall to the ground, which wouldn't be good at all, right? And so these other traits as well, the grasping hands, the nails instead of claws, all of these things are related to a lifestyle of living in the trees. These are all adaptations to an arboreal lifestyle. And so the importance of the eyes for that type of lifestyle is related to the reduction in the size of the snout, because as the sense of vision became more important than the sense of smell, the eyes are emphasized and the snout is reduced. As you know, dogs have excellent sense of smell and are often more reliant on their sense of smell than their sense of vision, and so you have an elongated snout that allows for extrasensory organs inside the snout. Dogs do not have an enclosure to protect their eyes, right? Their eye would be there and there's sort of soft flesh around the eye. Primates have protective bone around their eyes, and this is related to the importance of the sense of vision. And so there's a bony enclosure around the eye. When we look at different kinds of primates, we'll distinguish the different types of enclosures around the eye. So that's just an overview of what makes primates different from other mammals and the traits that they have. One other trait that I'd like to point out is the collarbone, the clavicle, right? Primates always have a clavicle. Not all mammals have a clavicle, right? Like this dog does not have a clavicle. Cats do not have clavicles, right? So those are some various features that distinguish primates from other types of mammals. Here is a basic primate taxonomy. Primate classification can be thought of as a series of levels, each one getting more and more specific. Every specific category also belongs to the larger, more general categories that are above it. So let's look at these taxonomic levels one at a time. We'll start with the most basic primate distinction. prosimians, which include lemurs, lorises, and tarsiers, and the anthropoids, which include the monkeys and the apes. Okay, so now let's look at the different types of primates. The first initial distinction is between something called a prosimian and all the other kind of primates, which are called anthropoids, and we'll get to the different kinds of anthropoids in a moment. So we have our prosimians. Here's a galago, also a bush baby, and here we have a monkey called a tamarin, and also a lemur skull here at the bottom. A lemur is a prosimian as well. So some of the things that distinguish prosimians from anthropoids in terms of their skulls is you've noticed that the prosimian is more prognathic, has more of a snout. The anthropoid has a flatter face, right? And you can see that if I hold the prosimian, the lemur, next to the anthropoid, you can see how much longer the snout is on the prosimian than the anthropoid. Other differences, again, is the increased brain size. The actual brain case part of the skull is enlarged relative to the rest of the skull in the anthropoid. The brain case size relative to the skull in the prosimian is a little bit smaller, right? And you can see that when I hold the lemur skull up, the size of the brain case relative to how long the snout is compared to the tamarin here, whose snout is very much reduced, but the brain case is enlarged. One other difference we can notice in the skulls between prosimians and anthropoids is that prosimians have something called a tooth comb. Many prosimians have a tooth comb, and it's just what it sounds like. The incisors in the lower jaw are quite thin, like the teeth on a comb, and they project forward. And this is what allows them to clean themselves with that projecting forward comb-like feature of the bottom incisors. Anthropoids don't have tooth combs. So if you ever happen across a primate and you notice they have a tooth comb, you know it's a prosimian and not an anthropoid. So another difference that you can notice between the anthropoid primate and the prosimian has to do with that bony enclosure around the eye that I talked about. So the prosimian has what's known as a postorbital bar, this piece of bone that goes behind the eye to protect it, sort of along the side of the eye. But you notice that you can still see through. It's not completely enclosed. There's an opening there. That's different than the anthropoid primate, who has both the postorbital bar, like the prosimian, but also what's known as a postorbital plate behind the eye. It's completely enclosed in bone. You can't see through that, right? It's enclosed with bone, unlike the lemur, the prosimian here, that you can see there's a lot of open space there. It's not totally enclosed. So this is another difference between prosimians and anthropoids. Prosimians only have the postorbital bar. Anthropoids have both the postorbital bar and the postorbital plate. One thing to remember is that taxonomies can vary, and some anthropologists prefer a slightly different classification at this most basic level. The difference between the two taxonomies is very simple, and it has to do with where you group the tarsiers. If you place the tarsiers with the lemurs and lorises, then we call that group prosimians, and everything else is an anthropoid. But if you place the tarsiers with the monkeys and apes, we call that group PLATYRRHINES, and the lemurs and lorises strepsirrhines. Returning to our original classification scheme, we just saw the differences between prosimians and anthropoids. Now let's look within the group of anthropoids, which can be divided into two categories: PLATYRRHINES, which are the New World monkeys, and catarrhines, which are the Old World monkeys and the apes, including humans. One difference between PLATYRRHINES and catarrhines has to do with the shape of their noses. PLATYRRHINES have sideways-facing, round nostrils that are widely spaced. Catarrhines have downward-facing, oval nostrils that are narrowly spaced. The second difference is in the dental formula. PLATYRRHINES have 3 premolars, but catarrhines only have 2. A third difference is that some PLATYRRHINES have prehensile tails that can grasp things like branches. Catarrhines do not have prehensile tails. So those are some key differences between PLATYRRHINES and catarrhines. Next, we'll look within the category of catarrhines, which can be divided into 2 different groups. On the one hand, we have cercopithecoids, which are the Old World monkeys, and on the other, we have hominoids, which are the apes and people. Okay, so now we looked at the difference between platyrrhines and catarrhines. Now we're going to look within the group of catarrhines. We've got cercopithecoids, which are the old world monkeys, and hominoids, which are apes, including humans. So some very noticeable differences between monkeys and apes, old world monkeys and apes, has to do with their manner of locomotion, right? So monkeys are quadrupedal, either terrestrial quadrupeds, meaning that they get around on all fours on the ground, or arboreal quadrupeds, meaning that they get around on all fours on the tops of branches. Apes are what's known as brachiators, meaning that they swing underneath the branches by their forelimbs, right? Forelimb suspensory motion is what this is called. And that has a suite of traits altered in the skeletons to allow them to do that versus standard quadrupedalism. So let's look at what those things are. One thing you'll notice is the length of the lumbar region, which is the lower back, from the last rib to the top of the hip bone. The lumbar region in the quadrupedal Cercopithecine, the monkey, the old world monkey, is longer than it is in the brachiating ape. In this case, we have a gibbon. A gibbon is a lesser ape, or Hylobates. The lumbar region in the ape is shortened. You'll notice also that monkeys have tails. Apes do not have tails. These are a critical difference. Another thing you'll notice is the orientation of the foramen magnum, the hole at the base of the skull where the spinal column enters into the skull. In a quadruped, it's more towards the back of the skull, where if you're on all fours, right, to be able to see forward, your spine has to come into the back of your skull. If you're hanging from limbs, the orientation of the spinal column into the skull is more at the bottom, because you're upward and to keep your face facing forward. So the placement of the foramen magnum on the skull is a difference between the cercopithecoid and the hominoid. Another difference you'll notice is the orientation of the scapula, or the shoulder blade. So in the monkey, the shoulder blade is more on the side of the body. In the hominoid, it's rotated towards the back of the body. Another difference you'll notice is the clavicle is elongated in the hominoid. Turn this sideways so you can see. The length of the clavicle, it's longer in the ape and shorter in the monkey. Some also differences in the forelimbs that you'll notice are that the monkey has an elongated elbow. This piece of bone that sticks out, extends at the base of the elbow. It's called the olecranon process. The ulnar olecranon process specifically, because this is the ulna bone. And this is a longer one than we see in the hominoid, which has no such extension at the end of the elbow. Now, all of these sorts of traits have to do with getting around suspended from the trees. So having a shorter lumbar region and no tail, and also having relatively long forelimbs compared to your hind limbs, helps with the momentum when you're swinging under the trees from your forelimbs. A shortened base and a longer top makes the swinging motion more smooth. It's also better to be able to completely extend your arm to be able to swing. You can imagine trying to do monkey bars with your arms bent. You have to be a lot stronger. So the full extension of the arm is helpful. Now, if you have this elongated elbow bone, that's going to prevent you from being able to extend your forelimb. The monkey, it's good to have this extra piece of bone because they actually bear their weight on their forelimbs because they're quadrupeds, and that gives extra stability to the elbow when you're putting weight on them. So those are why we see the differences in the elbows. In the monkey, the length of the forelimb and the length of the hind limb are relatively equivalent. That helps them when they're getting around on all fours, right? In apes, the length of the forelimbs is greatly longer than the length of the hind limbs, and that has to do with being able to swing under the trees. Some other things you'll notice, differences between hominoids and cercopithecoids have to do with their teeth, specifically the molars. So cercopithecoids, the old world monkeys, have what's called a bilophodont molar. Bilophodont, bi meaning two, loph meaning sort of a raised bump, right? A loaf of sort of like. So two loaves, right? And dont being teeth. So a bilophodont molar is a molar that has two loaves to it, right? One here and one here, a ridge down the middle. Now that is a special adaptation for the diet that cercopithecine monkeys have. Hominoids have what's known as a Y5 molar, and it gets its name because it has 5 sort of projecting cusps, points, tips on the molar, 5 of them, and they're in a configuration, 2 on one side and 3 on the other, that allows you to draw a Y in the grooves, as somebody has done on our model here. So hominoids, Y5 molars, Cercopithecines, Bilophodon molars. And those are some of the key differences between Cercopithecoids, which are old world monkeys, and hominoids, which are the apes. So there are a lot of skeletal differences between Cercopithecoids and hominoids, and many of these have to do with the fact that the apes have a complex of traits related to brachiation. Within the hominoid group, there are Hylobates, the gibbons and the siamangs, which are called the lesser apes because of their small body size. We saw a gibbon skeleton at the last station. And the hominids, which are the great apes, the chimps, gorillas, and orangutans, and the bipedal apes, humans and their bipedal ancestors. So let's look within this group of hominids at the great apes, the pongids, and the hominins, the bipedal apes. So at this station, we're just going to look at hominoids, the apes, and what makes the difference between different types of apes, right? So there are lesser apes, which we don't have represented here, the gibbons and the siamangs, you saw at another station. And then there are great apes, orangutans, gorillas, chimpanzees, and humans. So let's compare just the skulls at this point. So a few things to notice is the brain case size, right? So in the back row here, we have male specimens, and on the front row, we have female specimens. We have pongo, orangutans, gorilla, gorillas, pan, chimpanzees, and homo, humans, homo sapiens. So if we look at the brain case size, again, as we've looked at other stations, the size of the area that actually contains the brain relative to the overall size of the skull. If you look at these great apes, the male orangutan and the male gorilla, right? And also the male chimpanzee. So get a sense of that. Then if you compare the human, look how much larger the brain case size is relative to the size of our skull. It's almost the whole skull, right? Compared to other great apes. So that's one major difference. The great apes all have relatively similarly sized brains, around 400, 450 cc's. Modern humans, a great deal larger, 1400, 1500 cc's, somewhere in that approximate range, so almost 3 times the size of the other great apes. Another difference to notice are the size of the canine teeth, right? And so one difference we'll notice, if you look at all the male specimens, is just how large the canine teeth are in relation to the size of the other teeth, right? And even the chimpanzee, right? The procanines project, they're very obvious compared to the other teeth. If you look at a human, the canines are pretty much the same size as all the other teeth in the mouth, right? It's hard to even tell which one's the canine. You have to count incisors, canine, premolars, right? So reduced canines, greatly reduced canines in the humans relative to the other apes. Now there's a different type of another thing that's interesting to look at in terms of the size of the canines, and that's sexual dimorphism. So remember that sexual dimorphism is differences between males and females in the forms, right? Dimorph, 2 different morphs between males and females. This can take multiple forms. We'll look at a couple here. Some will look at the canine teeth, right? So if you compare the size of the canines in the female gorilla compared to the size of the canines in the male gorilla, quite a bit larger in the male than they are in the female, and that's very typical across the primate order. If males have enlarged canines, the female canines are often reduced, relatively speaking. So we'll look at the male gorilla as a perfect example of a sagittal crest. It's the piece of bone I'm holding right here. This ridge, almost like a fin or a mohawk on the top of the head, is called a sagittal crest. Now the function of the sagittal crest is to anchor the jaw muscles, right? The jaw muscles would attach up here. They come up through the zygomatic arch, or the cheekbone, come up through that opening and attach at the top of the skull. Now you only need this large sagittal crest if you have very large, powerful jaw muscles, which this male gorilla has. And so you can see the sagittal crest on the male orangutan as well. Quite a bit smaller than it is on the gorilla, but still noticeable. Now we look at the dimorphism, the sexual dimorphism between males and females. Here's the male orangutan, here's the female orangutan. The top of her head is quite smooth, there's no sagittal crest, right? The male has the sagittal crest, so they're dimorphic in that regard. Gorillas are also quite dimorphic in the feature of the sagittal crest, right? The female has just a little inkling of an increased amount of bone there at the top, compared to the male, of course, which has this enormous fin of bone on the top of his head. Humans are not really dimorphic in that regard, neither males nor females. This is a female, this is a male. Neither one has a sagittal crest. Humans are characterized by this very round, globular head, right? Very smooth, none of these bony protuberances that we see on many of the other types of great apes, particularly the males, right? The brow ridge, these sorts of things. Humans do not have all those extra pieces of bone. So another thing is also the prognathism. You'll notice if you look at the great apes, and the degree to which, if you look from the profile, the degree to which the face extends outward, prognathism, right, is reduced compared to other types of primates, but compared to the human, the flat-faced human, right, we have nearly no prognathism at all. We have extremely flat faces compared to other great apes, like this chimpanzee, right? So you can see the prognathism. Orangutan, gorilla, and chimp all have increased prognathism relative to the human, which is reduced prognathism. So a key difference between bipedal apes, like this hominin, Homo sapiens, and other types of great apes that are not bipedal, like chimpanzees, has to do with the shape of the pelvis. Here's a chimpanzee pelvis, and you'll notice some obvious differences. First of all, the length, the overall length from top to bottom is quite a bit longer than in the bipedal human. From top to bottom, the pelvis is shorter. Also, the shape of this iliac blade is flattened out in the chimpanzee, but has a curved shape in the biped. It almost forms a dish-like bowl shape of the pelvis in the biped. Some of the factors that have to do with the repositioning and reshaping of the pelvis in the biped have to do with the attachment sites for abductor muscles, things that help you keep your balance as you're walking around on just two legs, unlike the chimpanzee. So in the hominin, the Homo sapien biped, the muscles attach on the side, from the top of the hip bone to the side this way, whereas in a quadruped or a brachiator or knuckle walker, like a chimpanzee, the muscle attachments are across the back instead of on the side as they are on the biped. Another difference between the two having to do with bipedality is in the structures of the feet. So, as you know, chimpanzees' feet look quite a bit like their hands. They have opposable big toes. They maintain the grasping ability, the prehensileness of the foot like the hand. Humans who are bipedal use their feet to bear their body weight as they get around. Now the big toe is no longer opposable out to the side here and able to move in relation to the other toes. It's now in line with all of the other toes. And that has to do with greater efficiency as the foot is moving across the ground. If you had a big toe sticking out to the side, that would interfere with the smooth efficiency of the motion of the foot for a biped.
And that completes our taxonomy of the living primates. Here's another way to visualize this classification system as a series of nested boxes. Remember that each smaller box also belongs to the larger boxes that contain it. So we have all the primates in one big box, which we can then separate into prosimians and anthropoids. Within the anthropoid group, there are platyrrhines and catarrhines. And within the catarrhines, there are cercopithecoids and hominoids. Hominoids can be divided into hylobates and hominids, and hominids can be divided into pongids and hominins. This all might seem complicated to you now, but keep studying. Be patient and you'll get the hang of it.